Welcome to the next lecture, my dear students. So in this lecture we are going to do the problems. So this is the chapter name in your worksheet. So water demand and population forecasting in that worksheet. So we are doing the first question number 1. So it is previous GATE 1991, 2 marks. GATE 1991, 2 marks. So question number 1. So let us read out the question. The population of a city at previous consecutive census year was 4 lakhs, 5 lakh 58,500, 7 lakh 76,000 and 10 lakh 98,500. The anticipated population at the next census to the nearest 5,000 will be. So let us see the values. The given data is, the values are given 4 lakh and 5 lakh 58,500, 5 lakh 58,500 and 7 lakh 76,000 and 10 lakh 98,500. Okay, so first and foremost thing, here in this question no method was mentioned. He didn't mention to you do with the arithmetic increase method or geometric increase method, incremental increase method, nothing was specified. So we need to identify which method suits this kind of growth. So let us see. So 5 lakh 58 minus 5,000 minus 4 lakh is equal to how much it will be? It will be 1 lakh 58,500. Here the difference will be 1 lakh 58,500. If you look at the difference of these two, so the difference will be 2 lakh 17,500. 2 lakh 17,500. And this difference, here difference between these two is 3 lakh 22,500. Okay. So if you look at the difference here, it is 59,000. It is 59,000. It is 1 lakh 5,000. It is 1 lakh 5,000. Okay, so these are the differences. Now no method was specified here. Nothing was given as a hint. The population of a city at previous consecutive census was given and future census was asked. So in these questions, so we can do any method. So let us do with the arithmetic, because if you look at the dp by dt is completely increasing manner only. So is it increasing in a fold like 1.58 into some factor is equal to this, the same factor? If you multiply it with that, if it is coming, then you need to go for the geometric increase method. So that means the population is growing in an exponential way. The population is growing in an exponential way. So if the growth is increasing and decreasing, so the gap here is 59,000. The gap here is 1 lakh 5,000. So the growth, so this is growth of rate of growth, increase or decrease. So rate of growth is also increasing. So this is growth rate, and how the growth rate is varying is this. The growth rate is also increasing. So let us do this with the normal conventional method. So arithmetic method, first of all let us do this arithmetic method. So arithmetic method, Pn is equal to P naught into n into x bar. Okay, so latest known population is 3 lakh, sorry, latest known population is 10,98,500. So next decade is 1. So x bar will be the average of these three. So what is the average of these three? So average value will be 232,833. 232,833. 232,833. Okay. So if you add this, how much will you get? How much we will get? 10,98,500 plus 232,833. So it is 1331,333. 1331. Okay. Now here, so this dp is growing, not constant. This here dp is not constant. So this arithmetic method is giving some lesser value. Let us do this with a geometric method also. Pn is equal to P naught into 1 plus R by 100 whole to the power of n means again 1. What is R here? See, the R means R means here this by the previous population 1,58,500. So R1 is equal to 1,58,500 by 4 lakh. R2 is equal to 2,17,500 by 5,58,500. And R3 is equal to 3,22,500 by 7,76,000. So these are the values. Let us determine the values and let us find the same forecast using geometric technique. Okay, 15850 divided by 4 lakhs, that is 0.396. that means approximately it is 0.4. This is 0.4. And next one is 2,17,000 divided by 558,500. It is also 0.389, that is approximately it is also 0.4. It is also 0.4. So 322,500 divided by 776,000. It is also almost 0.415, 0.41 or 0.42. So if you look at this, R1, R2, R3 is approximately coming, means it is better to use a geometrical increase method for this, because the rate of growth R1 is coming constant, right? So here, so if you take R bar is cubed root of 0.4, 0.4, and it is also approximately 0.4. I will take it directly 0.4 only. So approximately I am taking approximately because all are nearing 0.4. So here this is R percent. So R percent, this is R bar. R bar percent means 0.4 into 100. So directly I will take this as 0.4. Okay, this as 0.4. So 1.4. This is 1. 1 decade means 1. So 1.4 into P naught. So 1.4 into P naught means what? 10,98,500. So how much it will be? So 1.4. This 1537900. 1537900. So this is the population from geometrical increase. This is the population from arithmetic increase, and there is incremental increase also. Incremental increase means you add something else here. So that is n plus n by 2 into y bar. This is y bar. See, I feel that this question, if you look at the data, geometrical increase method is the better value, better progression, better method, better technique to use to determine the forecasting, because it is suiting, this data is suiting the geometrical progression, geometrical increase method. So I suggest you to go with geometrical increase method, and this will be the answer. Okay. And you can also do this with the incremental increase which was given in your solution, but I don't suggest that, but because here in this problem nothing was mentioned. So first of all, how these methods are being classified. So where this growth rate is coming. So in the logistic curve, so where exactly this pattern is suiting. If you look at this pattern is matching with the rapid growth. See, it is almost getting double. It is also getting double. So if it is arithmetic, then it should be constant. The growth will be constant, then only arithmetic. So here the growth is not constant, so arithmetic is not a suitable technique to use. If the growth is erratic, that means here, if this is 59,000, if this is 40,000, that means there is a difference in the growth. But here also the growth is increasing in the same pattern, double. Here it is getting double, here it is getting double. That means incremental increase method is also a not suitable value, not a suitable technique for this, especially for this problem. For this problem, if you look at the R1 values, so it is coming equal almost. That means it is growing in the same pattern exponentially. That is what I mean. So that is why I prefer the geometrical increased forecasting technique only. Logically it is fitting to that technique only. So that is why I suggest you to go with the geometrical increase method, and the answer is 153700. Okay. Now this is the first question. Let us go to the next question. It is a theoretical question. Water distribution system are sized to meet the, this is a very simple question. Option A is maximum hourly demand. Option B is average hourly demand. Option C, maximum daily demand and fire demand. And option D, average daily and fire demand. See, here he is saying that is not only water distribution system is designed for. So I told you that water distribution system is designed for total demand or total draft, but that option was not present here. But total draft, again, total draft, what is total draft? It is maximum of coincidental draft and maximum hourly requirement. But the maximum hourly demand was also given, and maximum daily demand and fire demand was also given here. So these kind of questions, actually both A and C, whichever is maximum, that needs to be provided as the total demand. But the question was not given properly. Okay, so generally we design for total demand, total draft. So option A and option C both are correct, but whichever is maximum, that we need to provide. Okay, so that is question number 2. Question number 3. So question number 3 is 2004 GATE. So question number 3. The present population of a community, it is GATE 2004, 2 marks. The last question of this topic. The present population of a community is 28,000 with an average water consumption of 4,200 meter cube per day. The existing water treatment plant has a design capacity of 6,000 meter cube per day. It is expected that the population will increase to 44,000 during the next 20 years. The number of years from now when the plant will reach the design capacity, assuming an arithmetic rate of population growth. Assuming an arithmetic rate of population growth. Okay. So what is the given data? So given data, present population is how much? 28,000. P naught is 28,000. Okay. So daily consumption. So consumption is daily consumption is 4,200 meter cube per day. Design discharge. The design capacity (6,000 meter cube per day) is the design capacity, and population at 20 years is 44,000. 44,000. So after how many years? So this treatment plant will reach to the design capacity. So first of all, what is the demand? So first of all, what is the demand of the public community? What is the demand of community? So demand is equal to per capita demand. Per capita demand is equal to daily consumption by population. Present consumption by present population. So what is present consumption? It is 4,200 meter cube per day. This is present consumption. What is present population? It is 28,000. So let us convert this into liter. So that means into 10 to the power of 3 liter. Okay. So how much it will be? (25,600) 150. So this is 150 LPCD. So 150 LPCD is the demand. 150 LPCD is the demand. Okay. So with this demand, how many? So with this discharge capacity to how many population? This is per capita. This is per capita. So now what I will do with 6,000 meter cube per day, how many heads? How many heads will get water? That means here multiply this and this. Multiplying this and this, you will get per capita. You will get. So here this is 150 is liter per head per day, right? So heads has to go up. Heads has to go up. That means you need to divide this 6,000 with this. So that means is equal to 6,000 into 10 to the power of 3 liter per day. So I have converted this meter cube into liter. So I have multiplied it with 10 to the power of 3. So 10 power 3 liter per day by, this is the demand, per capita demand, 150 liter per head per day. So now this day, liter will get cancelled, this head will go up. So this is number of heads. So this is how much? So 150, 15, 40s. So this is 40,000. So 40,000 is the public total number of heads. 40,000 heads will get the water when the plant is running at its design capacity. When the plant is running at this design capacity. So now after how many years this population will reach, this 28,000 will become 40,000. That is what he is asking. After how many years this 28,000 will become 40,000. So for that, see here Pn is equal to, so here arithmetic, he told that use arithmetic forecasting technique. So in arithmetic forecasting technique, Pn is equal to P0 plus K into X bar or N into X bar. Okay, so now here we don't know this X bar value. We don't know this X bar value. To find this X bar value, use this data. That means P20, that is 44,000. 44,000 is equal to 28,000 plus how many decades are there? 20. After 20 years means 2 decades. 2 into X bar. That means what is X bar? X bar is equal to 44,000 minus 28,000 by 2. 44,000 minus 28,000 by 2. So what is the value of this? 44 minus 28. 16. 8,000. So that means it is 8,000. 8,000. So same formula I will use here. So this is 40,000 now. This is 28,000 only. So here I don't know number of years or decades. X is 8,000 now. So if you solve this, you will get N as 1.5 decade. That is equal to 15 years. That is equal to 15 years. That is equal to 15 years. Are you getting me what I am saying? Here, let us understand the question again. So the daily consumption was given as 4,200 meter cube per day. This is the total water in liter or meter cube we are sending per day to 28,000 people. To 28,000 people. So for one person, how much water is coming from this 42,000? For one person, how much water is going? So for one person, it is 150 liters. For one person, 150 liter per person per day it is going. So if it is 6,000 meter cube per day, then how many persons will get? How many persons will get? So 6,000 by this per head demand. If you divide, you will get number of heads. So this 6,000 can go up to 40,000 heads. This 6,000 will go up to 40,000 heads. Here, today's population is 28,000. When it will become 40,000? When it will become? Using the formula of this. So this is 40,000. This is today's population. And N is, I don't know. X bar also I don't know actually. So but X bar I can find using the data given here. So P20 was provided. That is why P20 is provided. So P20 is how much? 44,000. P0 is 28,000. So P20 is N, I know. N means it is 2 decades. Because 20 years means 2 decades. So 2 multiply, if I multiply it with 2, I can find X. So from this statement, I can find X bar as 8,000. So using this X bar here, I can find N. So N I got it as 1.5 decade. That means 15 years is the answer. So after 15 years, so this plant will completely exhausted. So you need another plant in order to cater the demands of the future population. So these are the questions, previous gate questions we are having. in this topic of water demand and population forecasting. So now what we will do, we will move on to the next topic, that is quality characteristics of water. Quality characteristics of water. So it's a very, very important topic, quality characteristics of water. Every year you can expect a 2 marks question from this, at least 2 marks, maximum 4 marks. So damn sure the question will come in water supply. 80% probability is there to come from this topic, second topic. It is quality characteristics or quality of water simply. See, a small concept actually that is not that much important to discuss, but why to leave a small thing also. So there is a small thing, that is factors affecting water demand, so which is not at all important for the examination, but so why to unnecessarily leave a small thing also. So let us write what are the different factors which affects the water demand. Factors, this is the last one. Factors affecting water demand. So size of the city, quality of water, system of supply, metering system, drainage conditions, habits and culture of people, climate, climatic conditions, socio-economic status, socio-economic status and pressure, size of the community, size of the city or size of the community. So these are the different factors on which the water demand will get affected, water demand will get affected. See here, when the size of the community is larger, the water demand will be more. Okay, if the quality of water is good, so more water we will use. System of supply. So there are two types of system of supply. One is continuous supply, one is intermittent supply. Continuous and intermittent. Continuous supply and intermittent supply. So continuous supply means whenever you want water, you will get water when you just open the tap. So that is continuous supply. Intermittent means they will fix some hours, morning 2 hours or evening 2 hours, like that. So in that time only you will get the water supply, that is intermittent. So continuous and intermittent supply. Metering system means when you charge the water, when you fix some cost price to the water, then the water demand will be lesser, because you will use water judiciously, because it is costly. It is not for free. If it is giving for free, you will waste the water. If it is having some price, then you will use it judiciously. Okay, that is metering system. So because of the metering system, the demand will decreases. Drainage conditions, if you keep on using water but the water is not going from your home, or the locality is not having proper drainage, the water is getting logged, so that in those conditions what we will do, you will have a tendency to use less amount of water because the water cannot be easily drained out. That is why in those conditions, when there is poor drainage condition, then you will use less amount of water. If the drainage condition is good, then you will use more water. So drainage condition, if it is poor, less water demand. Drainage conditions, if it is better, then you will use more water. So habits and culture of people, what kind of culture we are having, generally cleaning of home, so festivals and all. So these times when you are playing Holi, the water demand will be more. When you are playing some kind of Ashtami like that, so then the Janmashtami time also the water, that means how the festivals and culture, accordingly the water consumption will increases and decreases. Okay, so climatic condition, where if it is hot weather climate, then the water demand will be more, and cool weather climate like Jammu Kashmir and all, so there will be the water consumption will be very less. Whereas if you get tropical zones, tropical areas, the water consumption will be very high depending upon the climatic conditions. And socio-economic status, so if the socio-economic status is very well, they use more water. Okay, and socio-economic status is low, then they use less water. The demand depends upon the socio-economic status also, and the pressure in the pipe. So the pressure, so more pressure is there, more water will come within less time. So in those cases what we do, we generally cannot control the water. So that is why in those cases when the pressure is more, then the water consumption will be more and water demand will be more. And when the pressure is less, the water demand will be less, because of less pressure, the water comes very slowly. So that is why the demand will be very less. So these are the factors which affects the water demand, but this thing is not at all important for the GATE examination, because it is easily understandable and easily you can analyze this thing and all. So from this the questions will come very rarely. Okay, so let us discuss the next topic, quality characteristics of water. So quality characteristics of water. See here, in general, water, in various impurities will present in water in various forms. Generally, if you take the water which is chemically, we call it as H2O. H2O, we also call it as distilled water, which we use in our laboratory testings and all. So that is a purest form of water. That is purest form of water, which is simply the molecular, it is in its molecular form, that is H2O. Okay, but in reality the water cannot be in its purest form, because the water will travel in various planes. It carries various sediments, various kinds of chemicals. All those things will come and dissolve in water, because of which the water cannot be a pure in its pure form which is available outside. Okay, so that is why in this water, so there will be different kinds of impurities. Like there are basically categorized under three categories. So there are three categories of impurities. Those are physical, chemical and biological. So there are three types of impurities, that is physical, chemical and biological. So these are the three categories of the impurities. So generally, why we need to do testing all these impurities and all is, see, I told you already, it is like a full body checkup of water. In this topic, what we do is we will do a full body checkup of water. So whatever be the problems in the water, so we will suggest the treatments. So here, whatever be the problem, because we need to send the fit water for drinking. So the water which is fit for drinking, we need to supply to the people. So for that sake, so first we need to do a preliminary checks of the water quality, and we will do the suitable treatments, and after doing the suitable treatment, we will send the water to the community. So that is why we do physical, chemical and biological tests on the water. So what are the different kinds of physical, chemical, biological? Let us discuss. Physical, first of all, let us discuss the physical one. So physical means which we can see and which we can feel. Physical means which we can see and which we can feel. That is physical. Physical impurities. So there are physical impurities such as suspended solids, and turbidity and taste, color, and odor, temperature, so these are the different kinds of physical impurities. These are different kinds of physical impurities we will check in the water. If you look at the chemical impurities, pH, dissolved solids. See, suspended comes under physical. Suspended, which you can see and feel, suspended, but dissolved you cannot see. So that is, a dissolved solids will come in chemical. Alkalinity, hardness. So this is very, very important for your GATE examination. And metallic ions. And different kinds of dissolved gases. And also nitrogen compounds. So these are chemical. Now the third one is biological impurities. Biological impurities such as pathogens, simply pathogens. So pathogens which are microscopically observable, so they cannot be easily observable. So that is why, so these biological category will taken, pathogens are kept under biological category. So these are the physical, chemical and biological impurities of water. So all these characteristics we will discuss in detail. Okay, we discuss in detail and understand each and every concept in the next lecture. Thank you so much.